Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's say today's problem is sum of bit differences. So what the problem is saying is that we will be given an array. For example, the array is this, right? Containing only two elements. So what we want to do is we want to find out the sum of bit differences of all the pairs in the array. For example, let's take this example where there are only two elements. That is only one pair, right? So for example, what is the binary representation of 1? 0, 0, 1, right? Binary representation of 1. Binary representation of 2 is 0, 0, 1, 0, right? So these are the binary representations, and what we want to do is we want to find out the bit differences, right? For example, this is ith index 1, 2, 3, right? So we have found one bit difference here on the 0th location, right? And on the first location, we have another bit difference, right? 0 and 1, right? So in this pair 1 comma 2, there are two bit differences. Okay. Now they are saying is so this one, right? So they are so this one 1 comma 2 and 2 comma 1 is not one and the same thing. So we have to calculate the bit difference for this as well. We have to consider this as well. It's not the same pair. So again, 2 comma 1, it is going to be same two bit differences, right? Two bit differences. So what we want to do is we want to consider both 1 comma 2 and 2 comma 2. So the answer will be 4. If you see here, the answer will be 4. Okay. For example, if there had been another pair, right? Another element 1, 2, 3. So you would have wanted to calculate for 1 comma 2, right? Then 2 comma 2 comma 1 comma 3, 2 comma 3, right? So these were the three pairs, and like the 2 comma 1 also, right? 2 comma 1, the other way around, 3 comma 1 and 3 comma 2. So for each of these pairs, you have to calculate the bit differences, right? The bit differences and add them, sum them up and return. That's what you want to do. Okay. So so for example, let's take this example. Okay, 1, 3, and 5, right? So this is the array 1, 3, and 5. Now the brute force, what would have been the brute force approach, right? So for example, what should be the pair here? 1 comma 1, right? 1 comma 3, 1 comma 5, right? 3 comma 3, 3 comma 5, right? 5 comma 5, right? 5 comma 5 again, 3 comma 1, 5 comma 3, 5 comma 1 again, like the other way around, right? So these would have all the possible pairs, right? So if we go by brute force approach, we would have to take 0 to n, right? And again for j equal to 0 to n, right? So this would have given us time complexity of O of n square, O of n square. So what we would do in this, we'll have sum equal to 0 here outside, and for each, right, or each of these in each pair, right, we would have got each pair here, and we'll calculate the bit differences. So it would have given us O of n square as a time complexity. So the asked time complexity is O of n here. Okay. So let's quickly see how we can solve this problem. What should be the intuition, right? Let's take this example. Now we have 1 comma 3 comma 5, right? 1 comma 3 comma 5. So let's write the binary representation, right? 0 0 0. For example, what would binary representation of 1? 0 0 0 1. Yes, right? And if we consider in integer we have 32 bits, so 0 till, right? So 32 bits, right? So what is a binary representation of 3? Binary representation of 3 0 0 1 1, right? And 0. 5 is what? 0 1 0 1, right? 0. Okay. So this is the binary representation, right? So what will we do now? We'll start from here, right? This is 0th index, 1 index, 2 index, 3 index. It starts from right to left. It goes from right to left. So it starts from here. What we'll do, we'll keep the track of number of ones, right? On each bit, right? At the 0th bit, at the 0th location, how many ones are there? So in this one, right? We have across all the numbers, we have 3 ones, right? 3 ones. And how many zeros are there? Zeros are 0, right? So now if I want to calculate, so there is no bit difference here. There's no difference, right? So what will be the number of pairs? Number of pairs here. So it will be ones into zeros, right? Ones into zeros, which will be 3 into 0. It will give us 0. Okay, it will give us 0. Now let's consider this one, right? Now let's consider this one, right? We'll calculate the number of ones. How many ones are there? Ones here are 1, and zeros here are how many? 2, right? So 2 into 1 will give us the number of pairs, 2 pairs. 2 into 1. How? Ones into zeros. Ones into zeros will give us the number of pairs, 2. So there are 2 pairs whose difference. So let's validate this. How 2 pairs? So here, if we consider this 1 comma 1, 0, 1 comma 3, right? For 1 and 3, there is a bit difference. What is the pair? 1, 3, right? And for 3 and 5 also, right? 3 and 5 also, we have another pair, 3 and 5. Okay, 3 and 5. Regarding this, right? 3 comma 1 will consider this later on, this pair later on, and 5 comma 3 will consider this later on, right? But here for now there are two pairs, right? Answer equal to 2, 1 comma 3, 3 comma 5. So for example, answer now is 2, right? Now let's move ahead again. So we saw here, so here it is 1, I think. There's a third bit, right? Third, yeah. So now we'll again go ahead, right? So here we'll calculate for this one, right? 0 0 and 1, right? 0 0 and 1. How many ones are there? Ones are 1. How many zeros are there? 2, right? So what are the number of pairs? Ones into zeros, that is 1 into 2. 2 pairs are there again. 2 pairs are there, right? So how 2 pairs? So if you see 1 comma 5, right? 0 and 1. 0 and 1, and 3 comma 5, 0 and 1. So there are two pairs, right? There are two pairs. So we'll, in the answer, we'll add 2 plus 2, right? Equal to 4. Now, if you see here, all the zeros are same. There is no big difference going ahead, right? Then also answer is 4. So in the end, what we'll do, we'll return answer into 2. Why answer into 2? Because we have to consider these pairs also, right? 3 comma 1, 5 comma 3. Till now, we have considered these pairs, 1 comma 3, 3 comma 5. So we have to calculate the other way around as well. So we'll return answer into 2. Okay, so I hope you've got the solution. You've got the intuition. So let's go to the code. Before that, I'll request you to subscribe to my channel. Okay, if you got the solution. Thank you so much. Let's go to the code now. So let's first I'll show the Java code followed by C++. Okay, so let's say how we'll go. We'll have int I equal to 0, I less than 32, right? Because of the size of integer, right? There are 32 bits, right? 32 bits, as I said, right? There are 32 bits, and we want to check. We want to start with 0th bit. Okay, going till 32 bit, right? So first we're going to check all these bits, right? 0th bit across all the numbers. Okay, so this is a for loop for that. Then we have another for loop which will iterate through the array, right? Which will iterate to the array j less than n plus plus j, right? And what we'll have here, we'll have long ones to keep the track of ones, long zeros, right? Equal to zeros. Okay. Now what we'll do, for example, now we want to see, right, if the bit is set or not. If the bit is set for array of j, what we are going to, how we are going to do? We are left shift by I, right? Left shift by I. I'll explain you how left shifting by I. For example, if array of j is 1, right? What is the binary representation of 1? 0, 0, 0, 1, right? So what we are saying is array of j left shift by, right shift by I, right shift by I. So what is array of j? Array of j is 1. What is I currently? It is 0, right? It is 0. So it is saying that move this 1 by 0 places to the right. So this will remain unchanged. For example, if this would have been the case, right? For example, I is 1 in this case. I is 1, right? And arrow j is 2, right? 2 right shift by 1, right? This it is saying, right? So what is the binary representation of 2? 0, 0, 1, 0, right? And what it is saying, right shift by this complete right shift by one place by one place. So it will be 0, 0, 0, 1. So each bit will move by one place like this, right? It will be 0, 0, 1. So what we are each time checking. Now what we are going to do here, we did like right shift by I, and then we are doing AND operation, bitwise AND operation, okay, with the 0th bit to check whether the bit is set or not, right? So if the bit is set, it is going to return 1. For example, we moved this, right, to right shift by 1. So this was the result, right? 2 right shift by 1, it got 1 here. Now what I'm doing here, I'm doing bitwise AND here with 1, bitwise AND with 1. So what is bitwise AND with 1? 0, 0, 0, 1, right? Right? Now I'm checking whether this bit was set or not. Yes, it is 1 and 1 and 1 is 1, and the rest it will give 0. So we are getting 1 as a output, right? So in this case, we are going to increment ones, right? We are going to increment ones, else we are going to increment zeros, right? Plus, right? And then what we are going to do at the end of this loop, we'll have one answer, or maybe let's say long sum equal to 0, right? Long sum equal to 0. And what we're going to do, sum plus equal to ones into zeros will give us the number of pairs, right? Ones into zeros, and then finally sum into 2. I have already explained why sum into 2. For example, if this is a pair 1, 3, right? So we have to also consider 3, 1. So that is why whatever is the number of pairs, we have to do multiply by 2, so that we'll get these pairs as well. Okay. So yes, let's submit it. Oh, there's some problem. What is the problem here? Oh, expected return. Oh, spelling is wrong. Let's submit it. Come on. It's taking time. I think this is going to work. Okay, yeah. Let's see. It's taking a lot of time. Yeah. Yes, it is accepted. Let's quickly see the C++ code. It's almost the same, right? The only difference is we are taking a long over here, right? Ones, zeros, and everything is same. Everything is same what we have implemented in Java. Okay. I hope you have got the solution. Please subscribe to our channel and like the video. Have a happy, healthy, and a great day. Thank you so much.